And last type of thing we're going to talk about today, we're talking about asymptotes and wholes and rational functions. A whole is saying if the denominator and numerator have common factors, a whole will be in the graph. Now, the thing about this is it doesn't look too apparent here. So the first thing we do to look is if anything cancels out, and actually we notice that this degree is one higher than the other, but I'll show you something first. We better check to see if something cancels out first. All right, so I know if I factor this, all right, I bet if I factor it, it can be x plus 5 and x minus 2 all over x minus 2, right? Because we know that this means that the signs are going to be different. This means that the bigger number is going to be positive. 2 times 5 is 10, and we know if we add a positive 5 and a negative 2 together, we're going to get a positive 3. That's back from your factoring in algebra 2 and algebra. But also now we notice that since this is multiplication, only because it's multiplication that we can cancel out this x minus 2 here. So what ends up happening is before we even graph, we know in this equation that x cannot equal 2. X cannot equal 2. All right, because we're saying, well, before we even do anything to it, it looks like we have a horizontal asymptote, or sorry, a vertical asymptote at x equal to 2 because that makes the denominator 0, right? Well, in this case, we got it to cancel out. And in fact, all we have left over is y equal to x plus 5 divided by 1, which is just x plus 5. But we know that x cannot equal 2. And what ends up happening, because x can't equal 2 from the original equation, all right? What ends up happening is this graph looks exactly like x plus 5, all right, how we'd regular graph it. Just when we come to x equal 2, it's going to be a hole in it. So I know that I'm start up 5 because that's my y-intercept, 2, 3, 4, 5. And I'm going to go up 1, over 1, up 1, over 1. But we know that when we go over 1 the second time, that's x equal to 2. All we do is we put a hole here, and we continue to go up 1, over 1. And it's going to look just like that line, except for there's a hole at x equal to 2. So it's just a regular line, and it has a hole at the spot where we canceled out. All right. So, and it's not always going to just be as easy as y equals x plus 5. We might end up with a rational function that we have to graph, but we just have to remember to put a hole at that x value when we get to it. Okay. So let's move on to the second one. All right. Let's move on to the second one here. Looks like I have an x minus 4s that since it's all multiplication that these can cancel out, right? And I don't see anything else that would be able to cancel out now. So all I have now left is I'm going to have x minus 2 divided by x times x minus 3 squared. All right, and now the graph is going to look exactly like this guy's graph is, and we can figure out where the horizontal asymptotes are. 0 would make this undefined, right? A positive 3 would make this one undefined, right? Because that would make this equals 0. 0 times anything is 0. If I made this x equal to 0, 0 times 0 minus 3, which is negative 3, 0 times negative 3 is 0. So those are our horizontal asymptotes. We can go through our limit process to find our, or sorry, I apologize again. These are my vertical asymptotes at 0 and 3. We could go through, we could figure out our horizontal asymptote by dividing by the highest power of x. And when we do that, we'd actually have to FOIL this out and distribute our x through and then divide by our highest power of x. And we could come up with our horizontal asymptote, and then everything would look exactly like this graph, except for when we get to x equal to v4, that can't happen. There's going to have to be a hole, a circle like that into it. All right, so it'll look exactly like this graph. Just when we get to x equal to v4, there's going to be a hole in it. All right, so they're actually telling us to graph this. So let's graph this guy, I guess. So we said that there was going to be a horizontal asymptote at 0 and 3. So at 0, right along here, is my vertical asymptote, and then my other vertical asymptote is at 3. So 1, 2, 3, and I got a vertical asymptote in here. Okay. And then, so I was talking about the horizontal asymptote, not realizing that I was supposed to graph it anyway. Let's go ahead and find it. So I have x minus 2, and when I square out that bottom, I have x times X squared minus 6x plus 9, and then I can distribute my x through. So on the bottom, I'm actually going to have x cubed minus 6x squared plus 9x. And we're going to divide every single thing by the highest power of x. So when I divide every single thing by x cubed, I'm going to have x all over x cubed minus 2 all over x cubed divided by x cubed divided by x cubed minus 6x squared divided by x cubed plus 9x divided by x cubed. And we said we were going to take the limit of that as x approached 0. Or as x approached infinity, I apologize, infinity. Okay? So that means anywhere we see an x now, we're going to plug in infinity, and we can simplify this now. We can cancel out, this would be a 1, and this would be 1 all over x squared. This would be x cubed over x cubed is just 1. X squared divided by x cubed is going to be 6 all over x to the first power. 9x divided by x cubed is going to be 9 divided by x squared. So now anywhere we see a x, we're going to plug in infinity. So 1 all over x squared, 1 all over infinity squared, 2 all over infinity cubed. That's just 1. 6 all over infinity and 6 all over infinity squared. Well, we know that 6 over infinity, 9 over infinity, 1 over anything over infinity is going to be 0. And I know this is getting cluttered in a lot of colors. Sorry, this is 1. I got a little 0 happy there. This guy becomes 0. This guy becomes 0. Now what I have is 0 all over 1. I got my 1 from this guy. He didn't have an x in it. I didn't have to plug infinity into him. So when I got 0 over 1, my horizontal asymptote then is at 0, because 0 divided by 1 is 0. So now I know where my horizontal asymptote is. I know where my vertical asymptote is. And all that's left to do is I just need to pick points on this side of this horizontal asymptote, on this side of the horizontal asymptote, and on this side of the, I keep saying horizontal, vertical asymptotes. So we want to pick points on this side over here to see what it's doing. Pick points in the middle to see what it's doing in here. And pick points on the side to see what it's doing in here. All right. We can do one real quick. Let's plug in -1. When I plug -1 into this equation here, I get -1 minus 2 is -3 all over -1, and then times -1 minus 3 is -4. So I'm going to positive 4. So I'm going to have a -3/4. So when I pick -1, -3/4, it's down here. We pick another point. I'm guessing it's going to go something like this. All right. Then we want to pick points in the middle here, and I'm kind of running out of time, so I'm making this quick. To see what it's doing, there's a good chance it could be a parabola. I'm not sure it'll be. But let's go ahead and graph it. Let's go x minus 2. Let me bring my graph over here. Let's go graph. And it was, my equation was y equals, oops, x minus 4 times x minus 2 divided by, let's see, big parentheses here, x times x minus 3 squared times x minus 4. Close my bracket there and graph that. Oh, can't use brackets on this program apparently. So we'll use a big parentheses like that and graph it. And here is what it looks like here. Here's our asymptote at 0. Looks like it was up here. I must have did something wrong with my calculations because I was hurrying. It looks like it's an odd function in between, so this is why we pick points. This is our asymptote between 0 and 3, and this is on another side of our asymptote. So that we're graphing some crazy graphs, and you have to have a little bit more time than I had left in this video. But all you have to do is pick points, pick 3, 4, 5 points, get an idea what it's doing on each side of the asymptotes, and then connect the dots. Okay. I hope this helps. We'll see you in class.